Recording. Okay, so Gemma, can you see the screen? This point screen.
Yes, sir.
Excellent. Okay, a bit of revision quickly.
Yes,
So, just a few things to always keep in mind, and that is that your net force, right? That is just combined effect. By combined effect, I mean you add them together, right? Always keeping in mind that they're both positive and negative, right?
Yes, sir. Yes, sir.
The formula, the force applied or the force opposing is equal to F cos theta. That should be a theta. It doesn't copy. That should be theta. So what do I mean by that? Simply this. If that's the object and there's a force exerted on it, right?
Yes, sir.
And then the force that's having influence on it is parallel to the direction of movement or the intended movement. If it's in a straight line or parallel to the intended movement, that's easy. But now if we go to, we just save this. Let's go to our first case scenario, right? You have a flat surface, you have one body, forces parallel. I ask you, what is the net force? And you tell me, like I've been telling you guys for how long now, remember that thing, F net equals F applied plus F opposed, right?
Yes, sir. Yes, sir.
Remember that? Good. And they're all in a straight line. So basically, let's say you pick to the left, my left as positive, and of course, your net force will be 6 minus 4, which will be too easy. Okay. If we get to the, let's get a new one open here. If we get to a force which is not in, come off it. Don't tell me that, please, say, Lemo. Let me just, okay, let's wait a bit. Well, okay. If it's at an angle, then you need to work out the component of the force, which is again parallel to the direction of the movement. And the way we do that is F cos theta, where theta is always the
angle, sir.
Angle between the direction of the movement and the applied force. Right. Now this works anyway. Let's say you have a force there or an object there, and over here you have a force going that way, right?
Yes, sir.
With your angle there. And this is the direction of the movement. Then basically you can then say that cos theta or theta will be that angle.
Yes, sir.
Which will be larger than 90, which will then mean that cos theta is negative, and we can see it's negative because opposite to the direction of movement. Okay?
Yes, sir.
This is also easy. Flat surface, right? So if you see a flat surface, F cos theta, everything's running parallel to the surface.
Yes, sir.
Now, we get to the interesting part. I'm just going through everything, Liam, just to make sure that you are with me, right? Let's look at the inclined plane, okay? You want me to go through inclined plane again?
Yes, please, sir.
Okay, I thought so. Okay, that's cos theta, sine theta, by the way, cos theta. Okay, so first thing we should remember here is that the direction of the movement is now parallel to the inclined plane, right?
Yes,
so
sir.
the forces acting on this, we should work out that component, the two components, which is either up the slope or down the slope, right? That's what we should work out now. So the moment you see an inclined plane, that's what we have to look at.
Okay,
In order to do that, we need to look at the force which is acting on this body. Now, any body on Earth, there is gravity acting on it, right? And
Yes.
you should remember that gravity is always straight down, right?
Yes, sir.
Okay, happy?
Yes, sir.
Liam, are you with me? Excellent. So what we do now is we take that, the gravity, we take that as the hypotenuse of a right angle triangle. And we say, okay, so what we have here is a force acting perpendicular to the surface. Now that force is Fx or F cos theta or just F perpendicular, doesn't really matter what you call it. Now, if we look at that angle theta, right, you will see that this force, which is a component of the gravitational force, that force is equal to Fg, which is gravity, mass times gravitational acceleration, Fg multiplied by cos theta, and we also did that. Sorry about this little mess. The angle there, that angle theta, that angle is equal to that angle in on an inclined plane, right? Okay.
Sir,
Yes.
So is it the FG allowed that uses cos?
Yes. It's Fg perpendicular, because if we look at this triangle that I've drawn there, can you see that triangle?
Yes, sir.
If you look at that, you will see if that's the hypotenuse, then this side is the adjacent side, because it's adjacent to the angle we're working with, right?
Yes, sir.
And we know that your cos or your cos theta is equal to adjacent of hypotenuse, right? So cos of theta,
Yes, sir.
this in maths, is adjacent of hypotenuse, right? So therefore adjacent, we can rewrite this as adjacent is then cos theta times the hypotenuse, right? And
Yeah.
you can see there that the hypotenuse, as I said, is equal to the force of gravity or the weight of the object. Okay?
Yes, sir.
Excellent. Again, looking at this, we will see that there is also a component of the force of gravity working parallel to the surface of the inclined plane downwards. Now that is known as, that force is known as Fg sine theta,
Yes,
or
sir.
Fg parallel. And this one is the force that will always want to make this block go down the slope, right? So
Yes.
if you see a slope, there's a force making it want to go down the slope. That force is Fg sine theta. How do we do it? That is theta. There's theta, sine of theta. Fg is hypotenuse. Okay, right. Liam, I'm going to stop presenting now because
Okay.
I want to stop this. The video is too long and I can't load it on YouTube. So just give me a second, please.
Okay, sir.
Okay.